Hello, my students. My names are Joseph Medio from Right Way Schools. I would rather love to share something with you in science. Science is very wide, but I want to concentrate on primary level. Let me share with you something that I would like you to be concentrated, understand, and then put it in practical wherever you are. But before I go to the main topic, I would rather love to share with you something about the current situation, COVID-19. I believe you understand about the disease that is all around the world, COVID-19. I would like you to take precautions as it is being advised all over by all medias, and I would like to take this advantage to ask you, please wash your hands with sanitized water and make sure it is running water. Also, you can take a step ahead and use a soap to make sure that the virus are dead and they're not operating in your body. But also, take this advantage when at home and conserve our environment. For example, planting trees. You may improve our environment in one way or another. For example, when you plant trees, you improve the fresh air around the environment that you are in. But in all that, you shall be doing science. You shall be putting science in practical. I'd rather like to start my topic today. It's all about machine and work. What is a machine? A machine is anything that can simplify work. A machine is anything that can simplify work. My pen here is a machine. Why do I call it a machine? It is simplifying my job of writing. That is why I'm saying a machine is anything that simplifies work. But for today, I want to be a bit specific. I don't want to go to the way wide of machine and work. I want to concentrate on lever. A lever, is a simple machine also that simplifies work. It's a simple machine. And I would like us to do some revision, especially with the grade 7s who have already done this topic of lever. I would like us to do some revision on lever because I have discovered that most of my students are making mistakes when calculating this kind of machine of lever. But what do I want to do? I want us to calculate the values that helps to balance the lever or helps to put the lever in equilibrium. But before I start calculating, can we please come back or go back to the topic of lever and remind ourselves some bits on lever, parts of lever, parts of lever, parts of lever, parts of lever. Now this is the lever here itself, a simple lever here. This one is a part of lever, this one is a part of lever. What we call this part? What we call this part? What we call this part? Let me label them. A, B, C. But there is something else that I want you to understand in this study of calculation of lever. I also want you to understand this part and this part. Let me label this D and this one E. Now, what do we call part A? What do we call part B? What do we call part C? And then we have D and E. A. I believe you have started answering them there at home. A, we can assume this is a load, which we can name it as L. But we have B. B is a fulcrum or pivot. but we can call it, or we can label it as F. But we have C, which is necessarily known as effort, or we can label it as F. Now we have the load, we have the fulcrum or pivot, and then we have the effort. These are the main parts of a lever. These are the main parts of a lever. But there is a part that my student has been making mistake most of the time. That is from part A, this is from part A to part, let me call this X. From part A to part X. What we call this distance, that is D. What we call that distance, we can now relate it to the part A, which we called load. Now we combine them, the part A, and then we give a name to part AX. This is load arm. We can in short call them LA. So whenever my student you see LA, remember this is load arm. This is load arm. Alright. Part E. Part E is always calculated from C to X. This is the most mistakes that I have been seeing when I'm marking the work of calculation of lever. People does not discover where the load arm starts, where the effort arm starts. Remember, from C here to X, this is what we call E, and it is effort arm. Why effort arm? E, F. Why effort arm? We are relating it from C, that is, we call this effort. We call this effort. So we are relating it from this effort, and then therefore we call this effort arm. Effort arm, it is the same arm like this one, my hand, the arm, right? So this is the arm that holds the effort from the fulcrum to the effort. That is the arm that is holding the effort from the fulcrum to the point of effort. But it is the same case to the load arm, but the arm, like this one, it's holding the load A from the point A to the fulcrum. If, remember, if the part A does not touch or does not reach fulcrum, therefore it is not qualified to be load arm. If, for example, part C, that is effort arm, if it does not reach or does not touch fulcrum, it is not qualified to be called effort arm. Therefore, what do I want to mean here? I want now you to start thinking in the calculation of lever. I want you to start slowly thinking in the calculation of lever. Okay, now my intention was for us to think in now starting the calculation of lever, my student. Now, let me draw a simple figure here, and then I'll give you some tasks to do. Okay, you see now this figure? I hope it's visible now. Right? We say this is load arm, remember? We say this is effort arm, remember? Then we say this is fulcrum or pivot, and then this one we call it load arm, and then this one we call it effort arm. I believe we are moving together. I want to give you a task to do here. Now, from this point and this point, I'll give you a certain number. I'll give you 4 meters, for example. And from this point to this point, here I'll give you 4 meters also. But here the load, sorry, this is not load arm, but it is load itself. This is not effort arm, but it is effort itself. Sorry. But here now we have, let us assume this is 20 kilograms. Let us assume this is 10 kilograms. I hope we are together now, my students. We can see our simple calculation here. We have a simple diagram that is having 20 kilograms, that is load, and it is having 4 meters, that is load arm. We have the fulcrum. We have now the effort, that is 10 kilograms. And here we have 4 meters, that is for the effort arm. Now, how can you calculate? How can you calculate this diagram? You cannot calculate because you are already given all the necessary requirement. You are given already the load, you are given the load arm, you are given the effort arm, you are given the effort. Assume now you are not given effort. Assume now you are not given effort. And now you are told to calculate the value of x, for example. You are told to calculate in the following diagram, calculate the value of x. How do you calculate the value of x now here in this level to make it have a balance? Now, assume now you are given all this and you're not given x. Use a formula. There is a formula that if always you follow it, it will help you to answer such questions. The same questions of this kind will be answered when you use this formula, that is load multiplied by load arm is equal to effort multiplied by effort arm. Load multiplied by load arm is equal to effort multiplied by effort arm. This side we call it clockwise direction, and this side we call it anti-clockwise direction. But I don't want us to go deep to that. I want us to go to the calculations for today. I want us to get in calculations for today. We have two sides here. We have given load multiplied by load arm equals to effort multiplied by effort arm. If you understand this properly, if you understand how to calculate this simple diagram properly for today, now you will be able to calculate this complicated diagram here. If you understand how to calculate this simple diagram here for today, then you can be able to calculate this complicated diagram here. Now let us go slowly and calculate now. We have been given the part x to calculate, to solve for x or look for the value of x. Now we shall start with load. What is load here? We see load is 20 kilograms multiplied by, what is load arm? 4 meters equals to, what is effort? X. We are not given, it should be in kilograms, multiplied by, what is effort arm? It is 4 meters. Now let's see. Let us see. Okay, when you are given this way, you are supposed to multiply them and then you solve for x. Multiply this one by this one. 20 multiplied by 4, we have 80 kilograms per meters, which is equal to this one multiplied by this one, we have 4 meters per, 4x meters per kilograms. Now we need to remain with x only here. We divide here by 4 what? 4 meters. We divide here by 4 meters. Meters and meters are gone. 4 and 4 is gone. Meters and meters are gone. By 4 1, by 4 we have 20. What we remain with? We remain with x. which is equal to 20 kilograms. 20 kilograms. And that is the correct answer. That is the correct answer that will help our lever to balance. That is the correct answer that will help our lever to balance. I believe up to that point, now you understand something. Let me give you another simple calculation or another simple example. Another simple example so that we can start now solving the other problem. Giving you of the same kind. This is a lever here. This is a lever here. See this? It's kind of lever. We have this side. We have the other side. We have this part here and this part. Here we have, let's assume here we have 100 newtons. Here we have, let us assume this is 80 newtons. Here we have this, but we are not given, it's x. But here we have this, and we are given as 10 meters. Now we are told to calculate also for x. Calculate the value of x. Calculate the value of x. Now, how do I solve this value of x? I'm given the load and then load arm, but I'm not given the effort arm, but I'm given the same formula. Load multiplied by load arm equals to load multiplied by load arm equals to effort multiplied by effort arm. Load multiplied by load arm equals to effort multiplied by effort arm. Load we are given as 100 newtons, and then we are given multiplied by load arm, which is 10 meters, but which is equal to effort is 80 kilograms multiplied by x, which we can assume is in meters. Now, this one multiplied by this one, we get 1000 newtons per meters, which is equal to 80 multiplied by that one is 80x kilograms per meters. Now, we need to remain with x only. We divide by 80. This side 80 what? Newtons, sorry. Should be not newtons, not kilograms, sorry. Newtons, should be newtons, not kilograms. Alright. And the other side we divide by 8 newtons. Alright. Now here we have 8 newtons by newtons are gone. 8 by 80 are gone. Newton by newton are gone. 0, 0 by 8, 1. What do you get? 80 divided by 100 divided by 8. You get 1 because of 8. Remainder 2, 0. We have 2 because of 16. Point 0.3. Yes, if I'm not wrong, 0.2. Alright. So we have x equals to 12.2 what? Meters. That means our value of x will be 12.2 meters. And that is how we calculate in level. Now that is the second example, but I will give you the last example now, and now we get solving the question here that I had said earlier. That is how we solve in level. Now, let us take this example here. We assume now we have load 1, and now here we have load 2, but here we have the fulcrum, and here we have another effort. The first one, we have we have 4. Here we have 4 meters. Here we have 2 meters. Here we have 8 meters. Here we have X. Here we have 10, and here we have 10. These are newtons. Let us assume now we have a lever that has got 2 loads. This is a load. This is a load. This is an effort. Now we have that one. How can we solve it? We shall use the same formula. That is load multiplied by load arm equals to effort multiplied by effort arm. Now we shall take the first load. That is 10 newtons multiplied by this load arm. We'll start from here up to this point. Remember I said the true load arm should start from the load up to the factor. Remember I said the true load arm must start from the load to the factor. So this one will start from here to this point. This is where most students fail in calculation of rev. Now we shall take from this point up to this point. Although we have this one up to this and then we have up to here, we shall take both of them. So we shall take this one plus this one, then we have the complete load arm. 4 plus 2, we multiply by 6 meters into bracket plus the second load arm now. Mean the second load, we have 10 newtons multiplied by the load arm for this load must start from this point to this point, this point to this point. That is 2 meters. That is complete. Now we say equals now. The side of effort, we have this one, x as effort multiplied by 8 meters. We assume that this effort is in newtons, as the road is. So now from that point, we can see this one multiplied by this one, we get 60 newtons per meters. This one multiplied by this one, that is plus 20 newtons per meters, which is equals to 8x meters per newtons. No, we want to remain with x only. We want to remain with x only. Divide by 8x minus, we're dividing by 8 newtons, and the other side we divide by after addition. Let me add them first. We have 16 plus 20 is 80 newtons per meters, which is equal to 8x meters per newtons. Divide by 8 newtons here 8 newtons. What do we have now here? By newtons, by 8 by 8, by newtons, by 8 by 8, 10 here. What do we have now? X is equal to 10 meters. 10 newtons. So here we have x equals to 10 newtons. I believe you have understood how to calculate levels now. If I can go a step ahead and try to solve this point now, it is understandable now. You have understand how to combine the load arm or how to combine the effort arm. It's the same case. Now you understand. Let us try to solve the last problem here in our calculation of today in level. We take 3. And then we remember 3 kilograms is a load which must end with the load arm up to this point. So what we do here, we take the same formula. Load multiplied multiplied by load arm equals to effort multiplied by effort arm. The load on this side is 3 kilograms multiplied by this one plus this one. That is 7 plus 5, which is 12 centimeters, which is equal to, we have two of them. Put this one in brackets, then we plus 2 kilograms for the second load. 2 kilograms multiplied by 5 centimeters in brackets. What we have the other side? Effort. We have two efforts again. We have the first effort is 3. Let me do it here now. The second effort is 3 kilograms. 3 kilograms multiplied by P plus 4 centimeters into brackets. But we plus by 5 multiplied by 4. 5 kilograms multiplied by 4 centimeters into bracket also. Remember, we are plussing them with this one. Okay, now it is an equal sign, some equal sign. So we come to the other part and try to solve the problem together. In this part, we just put the like terms together. We take this one, multiply by this one. That is 3, multiply by 12. Here we get 6, here we get 3. That is 6. We have that 6. We have that is 6 kilograms per centimeters. That is 6 kilograms per centimeters. Then we plus with this one multiplied by this one, 2 multiplied by 5, we get 10 kilograms per centimeters, which is equal to this one multiplied, we have 3 multiplied by P is 3P plus 3P, remember it is kilogram per centimeters, plus 12 centimeters, 12 kilograms per centimeters, plus we have 5 multiplied by 4, we have 20 kilograms per centimeters. Now on that condition, we can put the like terms together. We take this, that is 6 plus 10, we get 46 kilograms per centimeters, which is equal to, we have now 3 plus 12. Should it be 3 plus 12? Yeah, 3 plus 12 we have 15 kilograms per centimeters plus 20 kilograms per centimeters. What do we have now? We have 46 kilograms per centimeters equals to, here we have 45 kilograms per centimeters. Hope we are moving on well. Alright, let us continue solving. We already now have the side of load and the side of effort. We already now have the solutions. Now what do we do? Remember, in the other side is in this side we have P to solve. That is, we have P to solve. So we need to divide here by 45 kilograms. And this side we divide by 45 kilograms. So what we have here now, kilograms, 45 gone, kilograms, and then when you divide by 45, it will be 1.6 something like 0.1. Then you can say P equals to 1.1 assume what centimeters, and that is correct answer. That is how we solve such problems. I'll give you an assignment, short assignment, the same question. We have here this diagram here. We have this here. We have this here. Here we can put 4 newtons. Here we put 2 centimeters. Here we put 4 centimeters. Here we put 2 centimeters. Here we put P again. And then here we have 10 newtons. Here we have 5 newtons. Now, can you now solve this? Here we have 8 newtons. Can you now solve this on your own way? I give you some few minutes. Calculate the value. Calculate the value of P. Calculate the value of P. I give you that an assignment to solve on your own. But remember, we need to keep ourselves safe as we continue being at home. Keep yourself safe from this coronavirus. In bracket, we call it COVID-19. Make sure you wash your hands each and every time and stop or avoid going to various places for meetings or so, because this disease is infectious. What we mean by infectious, meaning that this disease can be transferred from one person to another. But when you stay at home alone, you have made a bond, you have avoided the contamination of this disease. So please also remember to conserve your environment. Keep your environment clean, and if you have a space to plant trees, do that. Please stay safe. Let us keep in touch. Thank you.